Section 1.4, Part 5 video, still solving quadratic equations. We're talking about by the square root property. I've gone over the first example with you. I did it at the end of the last video. We want to continue now to look at the next example. And so here it is right here. X squared minus 20 equals 0. First, how do I know I can use the square root property on it? Besides the fact it says use the square root property, is because it is a quadratic equation and it has exactly two terms. What are the two terms? The squared term and constant term. All right, how do we solve this? Step 1. Isolate the squared term on one side, constant term on the other. That has to be done first. Step 2, take the square root of each side and introduce the plus minus symbol and then solve for the two solutions. Well, square root of 20, it's always plus or minus. 20 is 4 times 5, which is plus or minus 2 square root of 5. And again, you can enter them separately like that. Or if you find that plus minus button, you can enter it like this right here. Okay, this next one. Step 1, isolate the squared term. So that means subtract the 49 across. That has to be done first. Then step 2, take the square root of both sides. So I've done two steps here at once. I've subtracted 49 from both sides. Then take the square root of both sides. When you do, it's plus or minus, always, 7 and I because of the negative under there. So that's 7i, negative 7i. Okay? This next one. I did two steps at once here also. Step 1, isolate the squared term. Sorry about that. Isolate the squared term on one side. So that means I've got to subtract the 50 across. Then after you subtract the 50 across, it's going to become negative 50. Then take the square root of both sides. When I take the square root of both sides, so I did two steps there at once. Now, when you take the square root of this squared, it gets rid of the square and just leaves x minus 3. The square root gets rid of that square and leaves what's under there. Now, negative gives me the I. 50, 25 and 2, which is 5 square root of 2. Now remember, you can punch this in with your calculator, but you can't punch it in with the negative. You have to punch it in with that, and you have to remember to put the I in yourself. If you punch it in and put that negative under there, the calculator is going to give you an error. So you got to remember the I part yourself and then let it reduce. Now, add 3 to both sides. And when I add 3 to both sides, I get 3 plus or minus 5i square root of 2. You say, well, that's not two answers. Yes, it is. The first answer is 3 plus 5i square root of 2 and 3 minus 5i square root of 2. So that is two answers there. You say, well, why don't you go on down and add those together? Because I can't. You can't add 3 plus 5i square root of 2. That's not 8i square root of 2. You say, well, what if that square root wasn't there? Could you add them? Still can't add them. The only way you could add these two together is if that was just a number. Now, if it was 3 plus 5 and 3 minus 5, then yes. Because 3 plus 5 is 8 and 3 minus 5 is negative 2. But if this has an I or a radical with it, you can't add that number and that number together. They're unlike terms in that case. Okay? Got two more that you've already copied. Okay, step 1. Isolate the squared term. So that means add the 30 across. Now this is where you have to be careful. This square right here, this square is not on the 5x. this square is only on the x. So you've got to get rid of this 5 first. Now, if it was in parentheses, you wouldn't have to. If it was in parentheses, I'd take the square root right now. But if you take the square root the way this is written, it's going to be wrong. You've got to get rid of this first. This is a multiplying 5. You get rid of a multiplying 5 by dividing both sides by 5. When I divide the left side by 5, it just leaves x squared. When I divide the right side by 5, I'm left with 6. Now take the square root of both sides. And when I do, I get x equal, always plus or minus, and no, square root of 6 does not reduce, and so that is your final answer there. You say, well, the 6 breaks up as 3 times 2. That still won't reduce. Okay, now let's look at this one. You've already copied this one as well. Step 1, get the square term on one side, constant term on the other. So I want to add 18 to both sides. Step 2, take the square root of each side. Take the square root of the left side, take the square root of the right side. Now when I take the square root of the left side, I just get 2x minus 4. When I take the square root of the right side, plus or minus, always, and then 18 is 9 times 2, and the square root of 9 is 3, square root of 2. Or again, use your calculator. If there had been a negative under here, you'd have an I right there. Now I got to get the x by itself, so I have to do two things. First, I have to add the 4 across. So put that 4 here. And then when I do, divide both sides by 2. And then right here, the 2's cancel. And then this 2 is under both of these terms. Now, if you're not careful, you will be real tempted to cancel that 2 into that 4 and put a 2 right there. They do not cancel. The only way you could cancel this into this is if this 2 went into both of these. And it does not. So, now like if this was a 6, you could divide 2 into both in that case. But if it doesn't go into both, I would just, you can't reduce it. I just leave it like that. 4 plus or minus 3 square root of 2 over 2. Now, if you enter it on the computer, you can still break it into 2 parts. 4 plus 3 square root of 2 over 2, comma, 4 minus 3 square root of 2 over 2. So it's still 2 solutions. Now, don't write this one down. This takes me to my next problem I want to talk about. All right, so let's look at this one right here. Let's suppose I wanted to solve this one by one of the 2 methods that we've covered. All right, let's see. What 2 methods have we covered? The factoring method. All right, what does the factoring method say do? Step 1, bring all the terms to one side, set it equal to 0. Bring all the terms to one side, set it equal to 0. That's done. Step 2, factor this. Well, that's the problem. 59, this is an easy case. X squared, x and x, signs are the same, both negative. 2 numbers that multiply to give you 59 that add to give you 6. That won't factor. So I can't solve this by the factoring method. Well, let's try the square root property. Can't use the square root property either. The reason I can't use the square root property is this has a middle term. Remember the square root property, you can only have a square term and a constant term. I have a middle term also. So this is a quadratic equation that has 2 solutions that neither the factoring method or the square root property will work. Now for those of you, if you had me for intermediate the first part of the summer, remember we covered the factoring method in section 5.8, and we covered the square root property in, I think it was section 8.1. But those are the only two methods we covered. And I told you when we got into college algebra, we would cover other methods. So the two methods that we have covered so far in this section will not solve this quadratic equation. And that takes us into our next method, which is called method 3, called completing the square. Now, before I discuss that, let me show you something. Let's suppose I ask you to solve this problem. You don't have to write this down. Let's suppose I ask you to solve this problem instead of this one. Now, can I solve this problem right here? Yes, I can. How do I know I can solve this problem? Because remember, the square root property says you can have two terms only, your squared term and your constant term. As a matter of fact, we did this exact problem just a minute ago. If you'll flip back and look 2 or 3 examples back, you'll see that very problem right there. And so we have solved this problem before. So do you agree with me that we can solve this one by the square root property, but we can't solve that one? Everybody agree? All right. Now, it turns out yeah, we got enough. This problem right here and this problem right here is really the same problem. Now, do they look the same? Oh gosh, I know they don't look the same. But it turns out they're the same. But which one is workable? This one. Which one is not workable? This one. So if I give you this one, we can solve it right now. But if I give you this one, we can't. Let me get a little ahead of myself. In just a minute, I'm about to show you if I give this to you, I can't work it. So what we're going to do is we're going to make this problem look like that, since it's the same. Now, how do we make this problem look like that problem? That method, the method number 3, completing the square, is going to give you the steps. It's going to give you the recipe on how to make this problem look like that one right there. Let me give you an example. Let's suppose you're making a cake. And you make the cake and you put the flour and the eggs and all the other ingredients, you stir it up in the bowl. And it's sitting there on the bar. Now, you take that cake and you put it in the oven and you bake it. When it comes out of the oven, does it look different than before you put it in the oven? Well, yes, absolutely they look different. But they're not. It's the same ingredients. Everything is exactly the same. They just look different. This problem and this problem is the exact same thing. It's just that this one is workable. So what we're going to do, if I give you a problem that you can't factor and you can't use the square root property on it, we're going to rewrite it and put it in the oven and cook it. And we're going to make it look like this. Once I make it look like this, I can work it. And the way you do that, going from here to here, is called completing the square. And I will give you that recipe in just 1 second. But before I give you the recipe, I want to show you one more thing. I want to show you that this problem right here is exactly that right there. I just want to show you. Don't write this down. So I'm going to start here and end up right here. Just watch. X minus 3 squared plus 50 equals 0. Now, what does it mean to square something? Say it times itself. Plus 50. Now, I want to FOIL this. X squared minus 3x minus 3x plus 9 plus 50, which is x squared minus 6x plus 59. So see, that does look like that. Now you say, Mr. Renner, why on earth would we ever want to make this look like this? We wouldn't. Because I can't deal with this, but I can this one. But what we want to do is we want to make this look like that right there. And that's called completing the square. So, let me give you a couple of notes on completing the square, and that will close out this video. In the next video, we will actually begin working the problems. As a matter of fact, in the next video, I will actually take this problem and make it look like that so it is workable. But before I do that, I need to give you a couple of notes. Take down this first note. Still in section 1.4. Completing the square solves all quadratic equations. Completing the square solves all quadratic equations. Now, if you're thinking a little bit, you're sitting there thinking, wait a minute. Factoring method doesn't always work. Square root property doesn't always work. But completing the square does. That's right. So if completing the square always works, then what's the obvious question? Why not always use completing the square? And the answer to that is because completing the square, though it works all the time, is much more involved. So if I've got a little bitty problem that I can use the square root property on, it's a lot quicker to use square root property. If I've got a little bitty problem that I can use the factoring method on, it's a lot quicker. So completing the square, though it solves all quadratic equations, I will not use completing the square on a problem that could be factored, or I could use the square root property on it. Okay, now let's start out and let me give you the steps to completing the square. So title this note, Steps in Solving by Completing the Square. Steps in solving by completing the square. Step 1. Put the equation in standard form. Put the equation in standard form. And then out beside that write this. ax squared plus bx plus c equals 0. So basically what that means is put it in the right order. Step 2. Make the coefficient of x squared a 1 and the coefficient of x be even. Now, I know that makes absolutely no sense, but I'll talk about that when we get to the steps. Step 3. Move the constant to the other side. Move the constant to the other side. Let me say again about step 2 before you panic too much. Step 2, there's nothing you're going to have to do. You will never have to do anything on step 1. You're going to always go from step 1 to step 3. I'll explain that when I do the next video. So step 3, move the constant to the other side. Step 4, take half of the middle coefficient, COEFFICIENT, take half of the middle coefficient, square it, and add it to each side. Step 5, factor the left side, which will be a perfect square, and simplify the right. And then step 6, use the square root property to complete. Now, let me say again, that's 6 steps, but really you're only going to have 5. You know, you could, if you wanted to, don't, but if you wanted to, you could draw a line through step 2, and then you'd have step 1, step 2, 3, 4, 5. You could totally do away with step 2, but you'll see why I'm mentioning this when we get to the completing the square problems that I'm going to work with you. All right, so write these instructions down. Solve by completing the square. Solve by completing the square. And then I want you to write this problem right here. This will be the example that we do in the next video. Just copy this. And what you'll see when we follow those 5 or 6 steps that I just gave you, we're going to end up being back right here. And when we get back right here, we can work it. But we got to use the recipe to get back right here. This is kind of like, if you will, this is the cake in the bowl, but it hadn't been cooked. It's not in the oven, so it ain't ready to eat yet. I'm not ready to deal with this. I got to make it look like that so that I can deal with it. And that process is those 6 steps that I just gave you, called completing the square. So this completes section 1.4 video, part 5. We will probably have 2 more videos to complete this section 1.4.